Hi everyone, so this video we will talk about section 3.1. We will defining the derivative, okay? So first we will look at what is secant line and difference of quotient and what is the tangent line, the graph at the point, okay? So in calculus or in mathematics, if you have a graph, let's say you have a graph, and I'm gonna pick any 2 points on the graph and I call it P and Q. Okay, so if you have a graph that is a function f of x and you have any 2 point PQ on the graph, connect that 2 point at the line. This line will be called the secant line. Secant line. Okay, and the secant line can be found, the slope of the secant line, slope of secant can be found by using the formula of difference of quotient. Okay, so let me label the point P and I call the point P, the x value on the point P will be my x and the y value on my point P will be f of x. Then from P to Q, you're gonna have the difference of h. So I'm gonna adding h into my first value, I'm gonna get my second point, which is x per h for my q. And the output or the y value of at the q is actually f of x per h. Okay, so f of x per h. So the slope of the secant slope is rise over run or y2 minus y1 equal over x2 minus x1. So the slope of the secant line can also found by taking f of x per h minus f of x over x per h minus x, right? Over the difference of y. The difference of x over the difference of y. I'm sorry, the difference of y over the difference of x, okay? So when you have over the difference of x, the difference between the x value is just your h. So instead of writing this, I can just write add divide by x. This is called the difference of quotient. Quotient. Okay, so the different quotient will be give you the slope of secant line. So there's another line is called tangent line. So what is tangent line? Tangent line. So if on the graph, I have the point Q and I move the point Q getting really close to the point P. Okay, I move the point Q right here. I move the Q in this side. So if when I move the Q, then my function, my graph f the line is also moving. Okay, the line is also moving and getting really close to point P. When I connect this line, I'm gonna have this line is called tangent line. Okay. So how do we find the tangent line, the slope of the tangent line? So the tangent line can be formed by moving the point Q, getting really, really close to point P. Okay, so when Q is getting really close to point P, isn't that the distance between the x and the x per h is really small, really small. The distance is really small, and we call that distance is getting almost zero because it's really, really small. It's almost getting zero. So the slope of the tangent line, is actually can be found by taking the limit of h approaching to zero, f of x per h minus f of x over h. All right, so the idea of the secant line is when one point on the graph getting close, really, really, really close to the other point, the secant line will become the tangent line. Because when it's getting right here, so if the point Q is right here, when I connect the line, it's getting really close, right? So if I get moved closer, 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 it's gonna become the tangent line. Okay, and the tangent line is look like you are actually going to 2 point because the second point is really, really, really close to x. So we just say the tangent line at the point x equal 1. So secant line is the line that getting to 2 point. Tangent line is the line that is really is actually just at 1 point on the graph. Okay, so the second point is really close to P so that you won't be able to see it. So we say it's the tangent line is the line that touch the function at only 1 point. Okay, but actually there are two because the other one is getting really close to it. Okay, all right. So we're gonna use that idea to find the equation of the tangent line to the function y equal x squared put 2 at x equal 1. So in order to find the equation of the tangent line, the first thing that we have to do is we have to find the slope. Okay, so to find the equation of the tangent line is y minus y1 equal mx minus x1. Okay, so you have your x1 already. x1 is equal to 1. So we can find y1 by putting x1 into the y. So y gonna equal to 1 squared per 2, which is 3. So we have the point x1, y1 is 1 and 3. Okay, so which is good. And now I need to find the slope of the tangent line. So by using the limit definition, the slope of the tangent is equal f of x per h minus f of x over h with the limit, right? With the limit of x approaching to 0. And because we know x is equal 1, so I can put in 1 into my x, right? So I'm gonna have limit of x approaching to 0, f of 1 per h minus f of 1 over h. Now we have to look for what is f of 1 per h first. So aside, I have f of 1 per h equal. So my f of x is equal to x squared per 2. So I have to replace my x by 1 per h. Okay, so everything under the square will be 1 per h. So we will have 1 plus x squared per 2. And that will give me 1 square per 2h per 2. And that turned out to be 3 plus 2h. And then I'm gonna put into my limit right here. So limit of x approaching to 0, 3 per 2h. And then minus, what is f of 1? F of 1 is the y value, it's 3. Okay, f of 1 is actually 3. F of 1 is 1 square per 2, which is 3. And that is the value we found above here. So we're going to put that in here, minus 3 over h. And simplify the expression. You can see 3 and 3 cancel out. So we got that gone. And the limit of h approaching to 0 of 2h over h. One last thing that we can see that h over x is, we can cancel out. They are the common factor. So the limit of that is equal to 2. So 2 is the slope of the tangent line. So now we're putting everything together. We will have y minus y1 is 1 equal m is 2, right? Times x minus, oops, y1 is 3, not 2. y1 is 3. Minus x1 is 1, so 1. So we have the equation of the tangent line is y minus 3 equal to x minus 1. Okay, if you want to, you can distribute the 2 and I will have y equal, no, y minus 3 equal 2x minus 2 and then add the 3 on both sides. We will have y equal 2x plus 1. So that is the equation of the tangent to the point x equal 1 of this graph. Okay, so now we're gonna put that on the decimal so you can visualize it. So I'm gonna go to decimal and I'm gonna grab my function y equal x squared plus 1. Okay, so this is the graph y equal x squared plus 1. We want to find the tangent line at x equal 1. So the point is right here at x equal 1 and 3. 1 and 3. Okay. Oh, this is the wrong graph. It's 2. Okay, 1 and 3. So we want to find the tangent line to this point. Okay, so let's look at the tangent of that. So I'm gonna putting the tangent that we just found is y equal 2x plus 1. So we're gonna go to 2x plus 1. Y equal 2x plus 1. And you will see that is the tangent line to the point at 1 and 2. Okay, so you can see the line is actually touching the graph f of x at this point 1 and 3 with this slope. Okay, so this is the equation of the tangent line.